Are we on? Hello, good day, geometry. We are going over CO18, identifying angle relationships formed by a transversal, which is our first definition, and only definition, I think, on this page, other than some key points. But a transversal is a, who remembers what SRL is short for? Segment, ray, line. So it's a segment, a ray, or a line that intersects two other segments, rays, or lines. Okay, so a transversal is a segment, ray, or line that intersects two other segments, rays, or lines. Okay, so I will highlight all the transversals that we have here in green, just so you can kind of see them. This line coming through here is a transversal. It intersects those two other lines. This one here is a transversal, right? Got a transversal here, and we got a transversal here. Apparently, I'm really bad at tracing.
I actually noticed one thing.
What's that?
They are all the same.
They are all the same diagram. Yeah, they are all the same. Yeah. Okay, so those would be the transversals on this page. Okay. Have I lost anybody yet?
Right there.
Scoot over.
Let's get still here.
Scoot over. Oh my goodness. Okay. And then when you have transversals, there are lots of angle relationships that develop. And what this whole objective is looking at is kind of locations of angles and what those relationships are. Okay. And the first one we have is corresponding. Okay. Corresponding angles, kind of your key phrase here, is same location, different vertex. Okay? When you think about corresponding angles, think about the same location but a different vertex. So an example of corresponding angles here, if I look at the angle in the top right corner of my first vertex here, the angle that corresponds with it is going to be in the top right corner of my bottom vertex here. Right? Same location. If you think about a vertex that's kind of in four angles to it, the top right angle, that's the location. The angle that corresponds with it in our other vertex will be in the same spot, that top right corner. Yeah?
Should always be top right.
No. The second pair of corresponding angles, if I were to highlight the top left angle in that first vertex, which angle would correspond with it in my other vertex?
So the top left of the bottom
Top left,
line.
right? Same location, different vertex. Okay? If I were to highlight the bottom right angle in my top vertex, what angle corresponds with it in my bottom vertex, in the other one? Great.
Bottom right.
The bottom right, same location, okay, different vertex. If I were to highlight the bottom left angle in my top vertex, which angle would correspond with it in the other vertex? The bottom left, right? Same location, different vertex. Okay, they correspond to each other. Joe, come back to your seat, please.
That's fair.
I don't know why this is such an issue today. Okay? Okay. Questions on that one? Okay. The next type, alternate interior angles. What does the word alternate mean? What does the word alternate mean? Blake?
Different?
Difference. Okay. Opposites. That's what I'm going to go with today, right? Alternate can kind of like a backup, but in this context, different or opposite. What does the word interior mean? Will? Inside. So what we're looking at here are inside of our parallel lines, angles that are opposite sides of the transversal. So if I highlight this angle, I said parallel lines, I shouldn't have said that, I just mean lines. We'll get to parallel lines in PO 19. But if I look inside my lines here, so I'm only focused on like this section, right? The interior, inside the lines. If I highlight the bottom left or the left side vertex here, the alternate interior angle will be the angle on the right side of the transversal. Okay? They're opposite sides of the transversal inside of the lines. Opposite sides of the transversal inside the lines. The other pair of alternate interior angles would be the angle on the right there, and then the angle on the left. Alternate interior. Joe? Shh. Opposite sides of the transversal inside the parallel lines. Drake?
Are they always gonna be one on top, one on the bottom?
Yes. Yep. Because these are the locations of angles at the different vertexes, right? Drake's asking, will there always be one angle at each vertex? Yes. Otherwise, you're dealing with like linear pairs and stuff like that. Yeah.
What if there's like 4 lines?
If I had another line coming through here,
Yeah, like two.
we'll get to that later on. I only put 2 angles or 2 lines in the definition, but really it's 2 or more, but we're just kind of starting small. Okay. But you can have multiple interior angles then if you got multiple lines. But we'll get there. Okay. Alternate exterior angles. The only difference between alternate interior and alternate exterior is now we're talking about angles that are outside the lines. Right? Kind of like exterior angle we learned about yesterday. So alternate still means opposite sides of transversal. Exterior means outside the lines. If I highlight this angle up here, it's on the left side of the transversal, outside the lines. The alternate exterior angle would be down here. On the other side of the transversal, also outside the lines. Alternate exterior angles. Alternate sides of the transversal, outside the lines. The other pair would be the top right one here, and then this bottom left one over here. Okay? Questions so far? With all the interruptions of seating and stuff, it really breaks the flow of teaching. I feel like I'm leaving things out. Just my train of thought gets interrupted, but I think I got everything. But any questions that you have? Drake?
Where are we gonna need to like use the alternate exterior angles and like stuff? Like when are we gonna need to like use these and like?
So the next 2 objectives, I'm not going to erase this. Can I answer that question after we go over the?
Sure.
Okay. So the last one is consecutive interior angles. We see that word interior again, which means inside. So we're dealing with inside the lines here. But the word consecutive means what? Consecutive.
In a row.
In a row, next to, right? In this context, it's saying that unlike alternate interior angles, consecutive interior angles are going to be on the same side of the transversal. Okay, so in red there would be a pair of consecutive interior angles. Same side of the transversal and inside the lines. The other pair would be same side of the transversal and inside the lines as well. Those are the 4 types of relationships that we're going to be talking about when we get to parallel lines, which will be coming up tomorrow. Okay. Questions on this before I erase it and answer Drake's question, and then get on to the bottom part. Okay. So Drake asked a valid question. Why do we care? When are we going to use this? What does this all really mean for us? If you look ahead into future things, we're going to be dealing with parallel lines. I brought up those symbols yesterday and said, asked if anyone knew what those symbols were. I think Sydney did or someone did. But they mean that the lines are parallel. And when you have parallel lines that are intersected by a transversal, a whole bunch of congruency relationships start to pop up. And we can use those to help us solve for missing angles. Okay? So that's the first thing there, right? Just kind of get those relationships down. If you look even further ahead into PO20, you'll see stuff like this. Okay, this is ultimately where we're headed. So that in a diagram such as this, with the information that is given, you will be able to solve for all the angle measures of every red dot. Every black dot. And then also figures such as this. Okay? Figures such as this. And big picture, what this applies to, you know, those of you that love your video games and your Fortnites and all that stuff, your EA Sports that looks so realistic, it's because, you know, they make it proportional, they make it fit, they make it realistic. Your animated movies, you know, your Pixars and your Disneys and all that sort of stuff. Obviously, all that animation is programmed, and this is kind of the basis of that, making sure everything fits together, right? And that's where we're headed with this. Okay? Does that answer your question? Okay. Do you even remember what your question was? Okay. So, but back to this here, right? Getting these relationships down. It says, in each diagram below, identify the transversal or transversals. Label one pair of corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. If you've got multiple colors, this is a great time to break those out. If you want to do each type of angle in a different color just to keep them straight, okay? If you don't, that's fine too. If you just want to abbreviate it with a C or an AI or an AE or a CI, that's fine too. Okay. But looking at this first one here, actually let's go to the second one because that first one looks a lot like what we had up top. Looking at the second one here, what's the transversal there? What's the transversal, Peter? The diagonal line coming right down through here, right? It's the one that intersects the other two lines. Okay. Now let's start with corresponding angles. You can pick any angle to start with; it doesn't make a difference. But let's just say I choose this one right here. Okay. Which angle in the other vertex is going to correspond with that one? Kind of look at the location of that top angle and think about it as upper left, right, and lower left, right. You know, because obviously these angles are all different measures here. You know, it's not quite as close as the top one, but upper left, upper right, lower left, lower right. What's it going to be in that other vertex, Drake?
Is it going to be upper right?
Not upper right.
On the bottom, like on the bottom line, the upper right.
Not upper right.
Upper left.
Not upper left. Nathan?
The very bottom.
So for this vertex down here at the bottom is a corresponding angle to this one. I mean, think about it as we have even though it's kind of diagonal, tilted, this would be the upper left, this would be the upper right, this would be the lower left, and this would be the lower right. Right? Which of those is going to correspond? So same location, different vertex, correspond with the angle dotted in green. Like
Lower right.
the lower right. Right? If we kind of put that up here, think about it as upper left, upper right, lower left, and lower right. Okay? It corresponds to that lower right angle. This is one of those moments where I'm not sure if you have questions or not.
This is Jessica. Can you dial 109, please? This is Jessica, 109.
Because you're giving me some really good poker faces here. Okay, let's try another one. Let's do alternate interior angles. If I identify this angle or mark that angle, which is in the lower left, it's inside of our lines here. Which angle on my bottom vertex is going to be an alternate interior angle with that one? Peter?
Upper left.
Not the upper left. Because remember, alternate interior is inside the lines, but alternate sides of the transversal,
Upper right.
the upper right. This would be the alternate interior. Opposite sides of the transversal, inside the lines. Opposite sides of the transversal, inside the lines. Okay? For alternate exterior angles, if I mark this one, my upper right, for alternate exterior, which angle is it going to correspond with? Thomas?
Bottom left.
Bottom left, the lower left, right. Outside of the lines, opposite sides of the transversal. Is that good? Question? Okay. Well. All right, so there's, and then the one that's probably the trickiest as far as location would be one where you've got this, okay? If you kind of think about it as inside and outside, these two angles here and these two angles are inside of the lines, and then you can look at left and right or top and bottom based off of that. And then the other two, these two angles here and these two angles here are considered outside the lines, and you can look at left and right from that. So is it kind of you have to kind of twist them or move in your head to get those positions there. But when you think about alternate interior, alternate exterior, make sure they're on the opposite sides of the transversal and outside of whatever lines the transversal connects. Okay. That's it for homework for today. That's all I wanted you to do. So you've got about 13 minutes to work on it now. I'm available for questions, especially considering I'm still not quite sure if you have any questions or not. But here for you. So. What?
The rest.
Yes, the rest of the page. So, Michael.
Yeah, what about the last one?
So the last one in the direction that says identify the transversal or transversals. There are multiple ones. So depending on which transversal you go with, then that will kind of depend on where answers go from there. All three of these could be considered a transversal, right? Because all three of them intersect two other lines. So it kind of depends on which one you go with, right? Which, what are you talking about? Oh, when we go to the consecutive? Sure, yeah. So, folks, before you move, the question was just asked, can you have the same angle represented in two different relationships? Yes. Now that we're on consecutive interior angles, you'll notice that, both interior angles of my top vertex have already been labeled. That's okay. If you want to pick the lower right one here for consecutive interior and label it with the upper right one here, that's okay. And an angle is part of more than one relationship. Okay? All right, homework for tomorrow, that is how you math.